Okay, so this is quadratic equations, part 2. We're solving using completing the square this time. Sorry about that. Last video got a little cut off at the end, just me saying m equals -1, 25. For that last problem, I had my timer set to cut it off. But anyway, we're now on number 9. And we're going to learn how to complete the square. Now, this may be brand new to you. There will be another worksheet that you can do with just all class problems or virtual class problems. So I'm going to do all of these in the video. So we have set ax squared plus bx equal to c to start. So that's the method I use. You may have seen it done differently. Some people get it all set equal to 0 and then move that constant over, but you can just cut out that step. So number 9 says n squared minus 43 equals 2n. So the first thing I did was write n squared minus 2n equals 43. From there, I want to build a perfect square trinomial over here on the left-hand side and set it equal to some number. Then I can use the square root method to solve. So it's a little trickier than what we were doing earlier, but the first thing to build the perfect square trinomial, I'm going to add b over 2 and square it to both sides. So I'm going to add a half b or b over 2 and square it, and I'm going to add that to both sides. So I will have n squared minus 2n, and then you can kind of, leave a blank, leave some space to put in that b over 2 squared. Equals 43, and I'm going to add that to both sides because I need to balance. If I only just make my perfect square trinomial and I don't balance on the other side, I've totally changed the problem. Don't want to do that. So b over 2 squared, in this case, I'm going to write that off to the side here, will be -2 over 2. It'll always come out positive because I'm squaring it. So I end up with -1 in parentheses squared. That's important. So I am going to just write that. I think I'll put that in red here. So that comes out to be 1. So I'll be clear there. So I'm going to add 1 to both sides. So because of the way I made this, and I did that, remember that when you have a perfect square trinomial, the middle term is double the product of the two ends, so to speak. So that's why this will work. Now I can go ahead and factor this. N squared minus 2n plus 1 will be n minus 1 times n minus 1. But I really don't want to write it that way. I want to write it as n minus 1 squared. N minus 1 in parentheses, that is. All squared equals my 43 plus 1 is 44 on the right-hand side. So now what I can do, it's very nice, I can take the square root of both sides. So I put a square root symbol around the whole thing, the n minus 1 squared on the left hand, and then equals plus or minus square root of 44. So when I take the square root here of the binomial squared, I am left with n minus 1 equals plus or minus square root of 44. So that might take a little bit for you to break down if you need to work with that, but plus or minus, we could write 44 would be 4 times 10, right? So we could pull out a 2, and then that leaves us with square root of 10. I mean, sorry, 11. I wrote 10. 11. So we have n minus 1 equals plus or minus 2 times the square root of 11. Our last step is that we have to add this 1 to both sides. And make sure you don't add it to the radical because it's not going to be like. We want to just add it, actually we want to put it right in here before the plus or minus. That's really important. So we would have n by itself equals 1 plus or minus 2 square root of 11, because we cannot add unlike terms. So, I mean, that radical kind of acts like, you know, an apple, and this 1 is like an orange. I can't put them together, just like an X and a Y. I wouldn't be able to combine unlike terms. So be careful of that. And that should look familiar to you. That's kind of how things end up looking when you use the quadratic formula. You may have seen that before. So again, I would want to write it in numerical order. If I split it apart, I would go 1 minus 2 square root of 11, comma 1 plus 2 square root of 11. If it were a word problem, you would calculate that out and just crunch the numbers and kind of round off. But usually we want all the skill work done with exact answers, so you would leave it in radical, simplest radical form. But you do want to simplify that. So these are kind of tricky, so you might want to pause the video and try it on your own, or just watch again. Number 10, a squared minus 14 equals 8a. So I'm going to rewrite this as a squared minus 8a equals 14. So I'm just kind of rearranging, subtracting the 8a, and adding the 14 on the other side. Actually, I'm going to leave a space right there after the 8a, and that way I can fit in what I'm going to add to both sides. So I have to figure out now what is b over 2 squared. So if I have minus 8 over 2 and square it, that would be minus 4 in parentheses squared. So that's going to be my 16. And I'm going to add that right next to the 8a and right next to the 14, because I have to do it to both sides. Always, always, always. So now you can form your perfect square trinomial. This will be a minus 4. So I'm just going to take the square root of my last number there. So square root of the first minus, because I have my middle term's negative, the square root of the second. And then just check back. Make sure if you were to square that, you would do a times minus 4 would be minus 4a, and then double it and you get your middle term. That's what we were working on a lot with the perfect square trinomials. That's why, so we could really relate it to this. So then we have 14 plus 16 is going to be 30. And I'll leave myself a little room on the left of that number. Then I'm going to go ahead and take the square root of both sides and write the plus or minus 30 there. So I am left with a minus 4 equals plus or minus square root of 30. Now I need to add that 4 to both sides. I also need to see if I can simplify that. 30 breaks down to 3 times 10, 2 times 5. No, I can't. I can just leave it that way. So the 4, you can think of it as bring it over the other side and change its sign if you're one that tends to add unlike terms. If this like kind of throws you off, writing it like plus 4 plus 4. You might want to be a little careful with that. So we have a equals 4 plus or minus square root of 30. And I'm just going to leave the answer right like that for this one. So I hope you're getting the gist of this. You can try number 11 is 3n squared minus 51 equals negative 12n. So see if you can set that up and figure it out. I will give you a hint with this one that you want to factor out a common factor first. You still always want to look for that whenever you can with these problems. It can't always be done like number 12. That one's going to be really tricky. So we have to manipulate some things on that. But I think this one should work out okay. So really, since this is an equation, I actually could just divide both sides by 3, which is the greatest common factor, divides into all of those, and it works out nicely for me. So I have n squared plus 4n, and then I left a blank, equals 17. So I need to figure out what my number is that I need to add on to make it be a perfect square trinomial. So again, I'm going to take half of 4. So remember, it's b over 2 squared. So half of 4 would be 2, and then square it, and I get 4. So I'm going to go ahead and add that in to both sides. So now from there, my binomial that I'll square would be square root of the n squared is n, square root of the 4 on the end there is 2. So my binomial is n plus 2 all squared equals 21. And then I'm just going to take the square root of both sides. So I end up with n plus 2 equals plus or minus square root of 21. I subtract 2 from both sides or move it over, change its sign. So I get n equals negative 2 plus or minus square root of 21. And square root of 21 cannot be simplified further. You can play around on your calculator a little bit with that. It helps you simplify, but do make sure you understand how to do it, just in case if you don't have access to a calculator on some of the tests or quizzes. All right, so this one is a bit trickier because we have this coefficient of 9 that's gonna kind of cause us a little bit of problems, but we can manage it. The first thing we want to do is factor that 9 out just of the expression here on the left. It's kind of like how we did factor by grouping. So we're going to just rewrite this as an expression of 9. We're not going to factor out the n though, just the 9. N squared plus 2n. And then we're going to write plus, and we're going to leave a blank here, because we are going to have to add on to each side here to get our perfect square trinomial. But it's pretty hard to do when we have a coefficient. That's why we pulled it out. But we have to remember it's still part of the problem. So whatever I add here has to be multiplied by 9 before I add it on the right-hand side. That's the step that people miss and have trouble with. So we're going to take half of our b, which will be 1 squared. So I'm just going to add a 1 in there. But remember, it's not really 1 on the right hand side. So because when I distribute this, so I'm just manipulating numbers, and this is a legal move, but it seems kind of weird. But 9 times 1, if I did that, then I'm really adding the 9 on the right hand side. So I'm adding 9 to both sides, because if I were to go ahead and expand this back out, then I will have added. So some people do it differently. You can follow a different method. Maybe I'll post an alternate video as well. But This way makes it real neat and tidy. You just have to, not forget to multiply that before you add on to the right hand side. So if we follow our process that we've used before, we would then need to complete this. We would get 76 here. And we're going to divide both sides by 9 to isolate our perfect square trinomial. So we would end up with n plus 1 all squared as our perfect square trinomial equals 76 over 9. Then when I take my square root of both sides, that's plus or minus, I'm going to end up with n plus 1 equals the plus or minus square root of 76 over 3, because I can just take that square root. This 1, the n plus 1, I'm just going to save room and rewrite that as n equals minus 1 plus or minus 76 over square root of 3. And from there, I can simplify. Square root of 76, if you crunch the numbers, it ends up being 2 square root of 19. So my final answer would be -1 plus or minus 2 square root of 19. And just that last term is over 3. You can make it all be over 3 if you want. You could multiply this -1 by 3 over 3 and have an equivalent fraction. So you would get -3 plus or minus 2 square root of 19 over 3 as probably your best final answer, but I think the other is fine. So now we're going to look at deriving the quadratic formula that we like to use so much. It's pretty convenient. And we're going to use completing the square. And I'll do that in a part 3 of the video.